evening, Titans. And this is the second day of solving a system of equations by using elimination. Remember yesterday, we first looked at solving this system and not having to do anything but add the two equations because we already had opposite coefficients for the y's, so they would eliminate and we'd end up with our one equation with one unknown. We also looked at yesterday having to multiply one of the equations in order to get opposite coefficients. So in this case, we multiply the bottom equation by 3. We'd have 15p minus 3q equals 33. And now we would have two terms that if I add them would eliminate because they have opposite coefficients. And we multiplied one of the equations in the system in order to make that happen. Well, today we're going to be looking at this system. If you look at this system, the x's are not the same, the y's aren't the same, so we're going to have to use multiplication. But there's no way of multiplying an integer by 2 to get to a negative 7. Multiplying integer times 4 to get to a negative 5. So in this case, we're going to have to multiply both equations by something to create opposite coefficients for either x or y. So the first thing we have to decide is which variable would we like to eliminate. And since both of them are already opposite signs, and they're both fairly small numbers, I would probably go ahead in this case just to choose to eliminate the x's. So to eliminate the x's, I'm going to need to multiply the top equation by 7 so I can get 14. And then I'm going to multiply the bottom equation by 2 so I can make that one also 14. And again, I probably decide that ahead of time knowing that 2 and 7 have a common multiple of 14. So that's what I'm going to choose to make the coefficient of x. So now, remember, the most important part here is that I have to multiply every one of these terms by 7. So that gives me 14x minus 35y equals a negative 98. And now when I do that to the second equation, multiplying everything by 2, I'm going to have a negative 14x plus 8y equals a negative 10. Now I have my opposite coefficients, and when I add my two equations, that's going to eliminate, and I end up with a negative 27y equals a negative 108. And I have my one equation with one unknown. I'm ready to solve by dividing both sides by a negative 27. And I get y is equal to a positive 4. Now again, remember my answer is an ordered pair, so I've only found half of my result. So I have the 4, but now I need to find the x value that pairs with it. To find the x, remember we go back to the original system and we pick one of the equations to substitute the 4 in for y. So I'm going to choose the top equation. So I'm going to use 2x minus 5 times 4 equals a negative 14. And so again, remember I replaced the 4 in for the y. So now I have 2x minus 20 equals a negative 14. I'm going to add 20 to both sides. I get 2x is equal to 6. I divide by 2. I get x is equal to 3. And now that completes my ordered pair, 3, 4. But again, I want to check my result. So I'm going to check it into the bottom equation. So So I'm going to replace the 3 in for the x and the 4 in for the y and make sure it checks. So I have negative 7 times 3 plus 4 times 4. That has to equal a negative 5. So I have negative 21 plus 16 equals a negative 5. Negative 5 equals a negative 5. It checks. So now I can assume that my solution to this system is the ordered pair 3, 4. And so that's solving a system using elimination where we have to multiply